Hello students, welcome to my video class. In this video we are going to do workout examples on function topic, or you can say function chapter. We have already done theory portion of entire theory portion of function. Now it's time for examples. Our first example is on your screen. Here we have to find, here our function is f, and our function is f. It is defined as fx is equal to 2x minus 3 and x belongs to real number. Then we have to find the value. We have to find the functional value of function f at x is equal to minus 5, and we have to find the functional value of function f at x is equal to a plus 2. So let's start. Solution. Here this is a given function, fx is equal to 2x minus 3, and we have to find the functional value of function f at x is equal to minus 5. Now the value inside the bracket is an input value. It's the input value. It's in the position of input variable, so it is an input value. X is the input value, so we have to input x. That means x is equal to minus 5 is the input value. We have to put x is equal to minus 5 when x is equal to minus 5. So now minus 5 will take the position of our x of function f. Now this position of f, the position of x will be occupied, will be captured, or you can say x is substituted by minus 5 throughout the function, entire function. Now you can just see minus 5 is in place of x. So on calculation, here x of a function f is replaced by minus 5. That's the thing happened here just now. On calculation, 10 minus 3 is equal to minus 13. Now this is the answer. Now next, for the next function, for this function, the input will be a plus 2. So x is equal to a plus 2. Again, when x is equal to a plus 2, now entire x of a function f will be substituted by a plus 2. Now our x is substituted, x is replaced by a plus 2. On calculation, here x of a function f is replaced by a plus 2. Yes, is equal to 2a plus 4 minus 3, and that means 2a plus 1 is the answer, and this is the answer, and these two are the answer. Now it is a very simple question. It is just a beginner's question. We have to be familiar with the input values and substitution of x by that value. So this text box is very helpful. X you don't have to write while you are making a note. This is just for understanding only. Now you can pause the video and you can write on your note copy. We quickly move to another slide, another question, example 2. Our example 2, now here fx, a function, is defined as fx is equal to 5x plus 3, x belongs to real number, and we have to find the value of x, and the given is fx is equal to minus 7. Output is given. If fx is given, then output is given. If x is given, then input is given. So our output, our functional value of function f is given. So we have to find the point where the function has the value minus 7. So we have to find the value of x. We have to find the point. The value of x is the point where the functional value of a function is minus 7. So let's start our solution. Here the given function is fx is equal to 5x plus 3 and fx is equal to minus 7. These two are given, and we can easily see both is fx. That means if a is equal to b, You can understand in this way also. If a is equal to b and b is equal to c, it's is equal to, don't get confused, it's is equal to, a is equal to b and b is equal to c, then we can write a is equal to c. So same goes here also. Fx is equal to 5x plus 3, fx is equal to minus 7. So we can equate both. 5x plus 3 is equal to 7, isn't it? And now 5x is equal to minus 7 minus 3. 3 changes its position, 3 changes its side. So its sign changes. X is equal to minus 2. This is our answer. X is equal to minus 2. And it's pretty easy equation. Okay, let's move to another slide. Another example, example 3. This is a very important question. The function is defined as gx is equal to 2 minus 3x. In the previous question, function is defined as fx. Now it's gx because f, g, h, they are the generic name given to the function. They are not defined. They are not fixed. They can be. That can be any name you can give. Now domain of the function is given. If domain of the function is given, then what is given? If x is given or fx is given. We have to be sure about it, and then we can easily find the range. Solution. Here y is equal to fx or gx. They are always written as y there because they are output. The function, entire function is an output. The functional value, that is y, is an output. Now domain is given. Now let's see. Reminder. There is a reminder. We have done this on theory portion. At last of the theory, we have summarized a very important summary was there in the theory video. Now, if a domain is given, then what is given? You can see domain is in the x column, isn't it? Domain in x column, there are antecedent, input, and pre-image and domain. So, if domain is given, then x is given. Then y, if y is given, then range is given. Here, x is given, and we have to find the value of y. So, if we are clear about it, then it is easy question. When x is equal to 2, if domain is given, then x is given. So x is equal to 2. Input will be 2. Here x of the function g is substituted by minus 2 because input value is minus 2. Input variable is x. Input variable takes the input value. So we have to substitute x. We have to replace x with minus 2. You can see on calculation. Minus 3 minus 2, that's why it is minus 6. So when x is equal to minus 2, value of y, this is y, a value of y is 8. This is value of y, which is 8. Now when x is equal to minus 1, we can again find the value of function g at x is equal to minus 1. We have to substitute minus 1 on in place of x. On calculation, the value will be 5 minus 3 minus 1. That's why it is plus. We have to be careful about sign. Now this is also y. This is also y. And when x is equal to 1, you can see g1 is equal to 2 minus 3 1. This is x, and x is replaced by. You can see in our function it is x right here. So x is replaced by 1 and 2 minus 3, which is minus. Now we have found all the y, and the collection of y is our range. So range equal to 8, 5 and minus 1. So this is important question, and this is important question, one of the important question. And you can pause the video. You can write the remainder on side of your copy. Copy this. We have to move quickly. In example 4, you can see the example 4 here. The question is opposite of the previous question. Here a range is given, and we have to find the domain. Now we will see the remainder table also. If f is defined as f is to x, then we don't have to worry about it. It is same. Fx is equal to 2x plus 3. You can write 2x plus 3. 2x plus 3. Now here y is equal to fx is equal. This is the function. This is the range. So there is a reminder table. See, range is given, means we have y, value of y, isn't it? Y is 2x plus 3. So we have the value of y and we have to find the value of x. Here, when y is equal to 1, you can see y is equal to 2x plus 3 is our function, and we will replace the value of y as 1, or 1 equal to 2x plus 3. Then 3 should change its side. 1 minus 3 is equal to 2x, minus 2 is equal to 2x, x is equal to minus 1. Now when y is equal to 1, value of x is minus 1. When image is 1, then its pre-image is minus 1. You can select that also. When y is equal to 5, y is equal to 2x plus 3, it is our given function. Then we have to replace the value of y. I replace the value of y as 5, then other are same, and 3 will change its side. 5 minus 3 equal to 2x, then it is 2 is equal to 2x, x is equal to 1. Now our domain is the collection of x. The domain is the collection of pre-image. So our domain is minus 1 and 1. Those example 3 and 4 are very, very important questions. You can write IMP on your copy also. So pause this video, complete this, and let's move to another slide. Now, if the pre-image of a function fx, the function is given as fx is equal to 3x minus 7 is 5. The pre-image of a function means this 5 is pre-image. Then what is pre-image and what is image? Pre-image, as we saw in our previous table, in previous slide, there was a table, a reminder table, where we saw the pre-image is always x and image is always y. So what is given? X is given and we have to find y. Here y is equal to fx equal to 3. So y is 3x minus 2. You see the remainder table. From the remainder table, it is quite clear that image is y and pre-image is x. So value of x is given and we have to find the value of y. Pre-image is equal to 5 is equal to x. So we can easily find our input will be 5 when x is equal to 5, f5. Now 5, x is replaced by 5. You can see the green, in the green color, 5 is in the green color, so it has taken the position of x, or you can say 5 has replaced x. 5 has replaced x. So our input variable is x. So input value takes the position of input variable. 15 minus 7, which is 8 by 2, which is 4. So our image is 4. Image is 4. Value of y is 4. So it is y. So our image is 4. It is very important question. And after we do selected questions, so every walkout example question on a walkout example are very important because only selected question are done. So pause the video, complete your tasks, and let's move forward. Example 6. What element in the domain? Now element in the domain set. Every element in the domain set, whatever element are there in the domain set is x, isn't it? Every element in the domain set is x. So has image 7 means this 7 is y. Image is y, pre-image is x. The domain set consists of pre-images. So domain set consists of x, isn't it? 1x, 2x, 3x, many x. So which x has image y under the function this? The question is pretty clear. Element in the domain set means it's x. We have to find the x, and image is 7 means y is 7. So we can easily find it here. Y is equal to fx is equal to 3x minus 2 is our function, and there is a remainder table as always. Now you can see pre-image is we have to find the pre-image. Actually image is given, 7 is our image, isn't it? And it is also the value of y, and we have to find pre-image because domain is a collection of pre-image. Domain is a collection of pre-image. All the pre-image are domain of a function. So here image y is equal to fx is equal to 7. So we have done question number 2. A quick reminder is there. You can see I will read what is written on your screen. Domain is a set of pre-images or element in the domain are pre-images. So it's a reminder for you, quick reminder. Now we can easily equate this value to 7. Pre-image is equal to x what. Now 7 is equal to we can easily equate these two values. I have shown one. A is equal to b, b is equal to c, so a is equal to c. So on cross multiplication it is 35 equal to 2x, now 38, and value of x is 19. So our pre-image is 19, so the element in the domain is 19. Here element in the domain is 19. This is also very important question. All questions are important because on workout example only selected questions are done. So each and every question are very important. You can pause the video, you can complete your work. 7. Now function is defined in a different way. You can see it is not fx, it is not gx, so it is fx plus 2, isn't it? So we have to convert that function fx plus 2 to fx, and it has a special procedure of doing so. So let's see. Here fx plus 2 is equal to 5x minus 7, and now you can just see this step and let's do the calculation here of this part only. Do the calculation of this part only. Let me do the calculation of this part. 5x, it will be 5x plus 10. Now you have to tell me one thing. Is there 10 in our question? 5x minus 8, we only have 5x minus 8, and this x we can see right here. So this plus 10 is an exceeding value, isn't it? Which we don't have in our question. It is extra value which we don't have in our question, so immediately we have to reduce this 10. So if you understand this part, from where this 10 came from, then this 10 came from this calculation of this 5x plus 2. Now how we know we have to write x plus 2? It is very easy. What is given in the question? X plus 2 is given in the question inside the function. If the input is given as x plus 2, then we just have to blindly write x plus 2. If here is x plus 1, then we have to write x plus 1. If there is a function f x minus 1, if it is given like this, is equal to 2x plus 1, then what we have to do is, you can see f x minus 1 is equal to, now input variable, we have to replace the input variable with x minus 1. Now we have to do same multiplication like this, and we have our plus 1 here. We write little bit further this plus 1, and we keep the gap here just to put the value after multiplication. Now just multiply 2x, the value will be in row, just multiply in row 2x, it will be 2x minus 2. Actually we don't have minus 2 in our question. You can just see we don't have minus 2, so we have to replace it. We just have to remove it by plus 2. It is extra value, so we have to immediately cancel it out. So now it is easy, isn't it? We just add same process. Whatever the value is inside, whatever the input value of a function, we just have to write this, and we calculate in a row, and that extra value we immediately have to subtract or add to remove it, and that's the procedure. And now you can see let's come back to our question. Now we wrote this by seeing right here in the function, and this 10 is extra value which I have already shown. Fx plus 10 is equal plus 10 minus 10, because this is the extra value we don't have in our question. The value which is in our question is minus 8, and which is written exactly minus 8, and this minus 10 is the extra value from here, from this bracket, from this calculation. Now let's see another step. It is 18, it is just a calculation, part of calculation. Now see this value, f dot 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 is equal to 5 dot 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 minus x. Now our input is x plus 2, Our input is x plus 2. So input is a generic name given to the function. It is not defined. We have said many times, we have heard many times. So it can be z, it can be x, it can be y, it can be p, it can be q. So just write x because we need x. Fx is equal to 5x minus 5x minus 18. This is our function. Okay, hope you understand. Practice some more question. It will be easy for you. Input is a generic, it is not specific, it is not fixed, so we can replace it with any other variable. We need x, so we replaced it by x. Now we have to find the functional value of function f at x is equal to 5. So when x is equal to 5, x of function f is replaced by 5. Now x is replaced by 5. On calculation you can see 25 minus 18, and that will be 7. That will be 7. Now there is an alternative method for this question also. Fx f5 equal to 7. Now there is an alternative method. You can see alternative method also, it's easy. Now here our given function is f x plus 2 is equal to 5x minus 7, and now in our alternative method we suppose x plus 2, whatever is the input of a function, that is supposed as z or any other variable. Now x is equal to 2 goes to another side, z minus 2. Now we can write fz, isn't it? We have supposed this to be z. This is z, so we can write z, and the x is replaced by z minus 2. On calculation you can see 5z minus 10. On calculation 5z minus 18. We have to find fx, but we got fz, so we don't have to worry about it, because how many times we have said is many times we have said, isn't it? Many times we have said that this input variable is a generic. It is not specific. It is not defined. So it can be changed. So we like to change it to x. So when z takes to x, fx is equal to 5x minus 18. So whichever method you like, you can follow this method. Okay, let's move. Now you can see there is a question. You can see the question, fx minus 1 is equal to x minus 1, then find the value of fx and 9. If you have understood the previous example, then you can easily do this question. Let's move forward. Example 8. The question is on your screen. It is a pretty simple question. Fx is equal to x minus 5, and we have input values are, our input values are say h and x plus h. These are our input values, and we have to calculate one a rational fraction, a value of rational fraction. A rational algebraic expression, in fact. Now solution. Fx is equal to x minus 5, it's given. Now our input will be h, because we have to find the functional value of function f at x is equal to h. So fh is equal to h minus 5. We can't subtract it, it's just like this. Now our input will be x plus h. It's in the question. You can see x will be replaced by x plus h. X plus h takes the position of x. Now that we can further calculate it, so we just leave it, and this is our answer, and this is also our answer. Now we have a rational algebraic expression, that is fx plus h minus fx. We have to substitute the value of x plus h, which is this fx we have here, right here, and let's substitute it. Now see, fx plus h means x plus h minus 5. X plus h minus 5 is the value of fx plus h. Now fx is x minus 5. Because there is minus sign, we keep it on bracket because the sign will be changed. See, in the next one the sign is changed. You have to be careful about this sign. Minus into minus, it is plus. So minus 5 plus 5 and minus 5 got is cancelled, x and x also got cancelled. So h upon h, which is 1. So the value of this rational algebraic expression is 1. So this is important question. It can be asked in examination also. Very easy also. So let's move to question number 9. Example 9. We have to find the missing component in the order pair. Now the function is defined as a set of order pair right now. In previous set of order pair also as a formula also. So this is also the same f. Same f. These both are f. Y is equal to fx is equal to 2x minus 1 is the given function, and let the missing component be p and q. For to make our work more easier, we suppose the missing component to be p and q. So the function became f is equal to 0, p and q3. Now these elements, this order pair belongs to this function. This order pair belongs to this function. So in an order pair, what are there in the order pair? The first part is antecedent, that is x, and second part is consequence, that is y. So we can easily find the value of the missing component, isn't it? Because the 0 is x, y is p, antecedent is x. You can say it is a pre-image, it is an image, it is a input, it is an output. So let's use that when x is equal to 0 and y is equal to p for the first order pair. For the first order pair, which is 0 comma p, first order pair which is 0 comma p, x is equal to x and y is equal to p, and we have our function y is equal to 2x minus 1. Let's replace the value of x and y from our function. See, y p, this is y, is equal to 2x, isn't it? X is replaced by 0 and minus 1. Exactly, we have replaced the value of x and y, so we can easily calculate the value of p, that is minus 1. And now next part, next order pair, that is q minus 3. Our order pair is q3, not minus 3, q3. In this order pair, pre-image is q and our image is y. Our antecedent is q and our consequence is y. Our input is q and our output is y. So we have, see, y, isn't it? 3 takes the position of y equal to 2x, q takes the position of x minus 1. We have just replaced the value of x and y, and on calculation 4 is equal to 2q and the value of q is 2. You can see value of q is 2. Therefore our missing components are minus 1 and 2. If you know the concept of x and y, then every question in the function will be easier. Let's move forward. Now there is a question for you. Try this. If hx is equal to 7x minus y be the function defined in the set of order pair. Here there are, find the missing components of the order pair. If you have understood the previous example, you can easily do this this question also. Let's move forward. Example 10. Now this is another important question. Now I think from here we have stepped on to long question. So our function is defined in a different way. Fx is equal to fx plus 4 is equal to fx plus f4. So let's start, and we have to find 3 results. One, f0 equal to 0, f minus 4 is equal to minus f4, and f8 plus 2, f minus 4 is equal to 0. Our function is x. First input will be 0. You can see first input will be 0, second input will be minus 4, but third input won't be it. So you have to be careful on this third part of the question. Now first input will be 0 when x is equal to 0. Then f0 will replace x, so wherever there is x we have to write 0. You can see x0, you can see x0. Now that will be f4, isn't it? 0 plus 4, it is 4, and f0 is equal to 0. You can see f4 minus f4 because it changes the sign. Now you can cancel it. then f0 is equal to 0. This is our first return, and it is pretty easy also, isn't it? Now our input will be -4 when x is equal to -4. You can see here our input is -4. Why we don't use 4 as our input? Because it's already in the question, isn't it? F4 is already in the question, and we don't need another 4. If we put 4 right here, it will be 4 plus 4. Then we may not be able to find this result. So our input will be x minus 4. Now see, x is replaced by -4, and this -4 and 4 get cancelled. That will be 0 is equal to 4. Then right here, see, right here, f0 is equal to 0. So this f0 will be replaced by 0. 0 is equal to f4 minus 4, and we can change the position of value according to our need, according to our quotient. So our quotient, according to our quotient, this f4 must go to left hand side. So you can see f minus 4 is equal to f minus f4 is equal to f minus 4. So it's easy. We just have to remember to use the result of first part, isn't it? F0 equal to 0. This result we derived here. So if we forget this, then we will get stuck here. Next is we have to find the value. This next is the third one. For third one, our input will be 8. No, if we input 8, then it will be 8 plus 4, 12. We don't need 12 in our question. We don't have to prove any 12 related question. So what we have to do is we just have to input 4. Now when x is equal to 4, if we input 4, then 4 plus 4, 8. We will get our 8. So f4 plus 4 is equal to f4 plus f4, isn't it? We need 8, and that's the 8 we get, and these are the like terms, so they are added here. They are the like term and they are added. Now we have to change the position of 2 f4 to left hand side. Now the next step is very important. Just see carefully. Now we changed this. We kept this inside the curly bracket, and we wrote 4. We can do this, okay? And now just see one example. If there is a minus b, then we can write a plus minus b. It is the same. This and these are same thing. So here also, what we can do, we can write plus, and we can bring it to inside the bracket, inside the curly bracket. And if we multiply, then this step and these step are fairly same step. If we multiply this step, now here by 2, then it will be minus 2f. So we can use this. It has a propose. We did by propose. Now see the underlined part here, and see the underlined part here. Minus f4 and minus f4 means we can substitute this minus f4 by f minus 4, isn't it? Minus f4 is f minus 4. Let's do it. See, we have just changed. We have just substituted the value of minus f4 as f minus 4, because we have proved that on our second part of our question. We have proved here. So we can replace the value now, and this is our answer. You just have to be careful here, right here, and now just understand the algebraic part of this. And a plus minus b, we can write this. These two steps are fairly same, and if you can remember this step, then if you understand this step and remember during the exam also, that will help you. Now similar type of question will be is given for you as an exam, as an exercise. So let's move forward. Try this. Exactly same way you have to do this question also. There was 4, here is 3, sometimes it may be 2 also. Question can be constructed in any way. Same, you have to do it in the same style. Another 11a. 11 has 2 questions, a and b. Now these two functions are equal function, and then we have to find the value of x. Their equal functions f and g are given and are defined as separately, but still they are equal function. Solution here. fx is equal to x square plus 2x minus 1 and x square plus 1. They are, according to question, we have fx is equal to gx because it's given they are equal function. Fx is equal to gx. Now we have to substitute the value of fx. See, 2x square plus minus 1 is the value of fx is equal to gx is x square plus 5x plus 3. Now on transposition, now we bring everything from right hand side to left hand side, and their sign changes. X square changes to minus x, 5x changes to minus 5, and plus 3 changes to minus 3. Now on subtraction, it is x square minus 3x. Now we have to remember the algebra from class 8. Now our product P is 4. Our product P is 4, and as the sign is negative, so we have to find the difference. D is equal to 3. Now we have to find two number whose product is 4 and difference is 3, and that number is 4 and 1, isn't it? We have done in class 8 also, 4 and 1. So we are going to factorize it. X square minus 4 minus 1x minus 4. Now 3x is replaced by 4 minus 1. 4 minus 1, and on multiplication you have to be careful here. Right here, minus minus plus, this plus sign. The student tends to make mistake in this step. X square. Now just taking common from these two, x is common, so x minus 4. Nothing is common means 1 is common, x minus 4. If we group x minus 4 and x plus 4, x minus 4 is common on now 4 term algebraic expression changes to 2 term algebraic expression, isn't it? Here we have 4 term, here we have 2 term. In these 2 term also x minus 4 is common, so x minus 4 is common and remaining is x plus 1. Now we have to do either or. Either x minus 4 equal to 0, that is x is equal to 4, or x plus 1 is equal to 0, or x is equal to minus 1. These are our answers, and this is the, I think, very easy question. You just have to do a little bit of algebra, then answer follows accordingly. And let's move to 11b. Before 11b, there is one question for you, a similar type of question, exactly similar. You can see on your screen, and then fx and gx are given. Then we have to find the value of x. 11b. 11b is also interesting and it is easy question also. We have to find the value of a. Now there are two functions f and g, and we have to find the functional value of function g at x is equal to 2, and we have to find the functional value of function f at x is equal to 1. We do those steps separately, and we combine and we find the value of x. Now here these three are the given part. Function f to x plus a is the value of a we have to find, and this is the unknown variable. 9x minus 6 is g, and g2 is equal to f1. So first we have to find g2, means when x is equal to 2 in function g, not in function f. It must be in function 2. 2 is the input for function g, so it will replace the value of, it will replace the x of function g, not function f. Now it's 18 minus 6, that will be 2. Now we have to find f1 also. To find f1 means 1 will be the input for function f, x is equal to 1. Then f1 is equal to 2 plus a. And now according to question, g2 and f1 are equal. G2 and f1 are equal, so value of g2 is 12 and value of f1 is 2 plus a, which we have found here, which we have on right here and here. On calculation, a is equal to 10. A is equal to 10. This is pretty easy question. Now you can pause the video, you can complete your work, and you can again start. Example 12. Now this is another very important question, and lots of calculation will be shown on your screen, and you have to follow each and every step very carefully. Now solution, the function is this is the linear function. Let me tell you, this is a linear function because x has value 1. You have to understand this, and you can suppose the linear function to be in any way. And here in the question it's given as mx plus c. You can just write ax plus b also. Okay, this is a linear function, ax plus b, ax plus b form. you can define like cx plus d also, ex plus f also. But right here it's given mx plus c, then we will follow our question, and, we will find the value of mc fx, and we have to find 1 2 3 4. There are 4 unknowns. So let's start quickly. Fx f4 equal to 11. Now you have to know what is this 4 and what is this 11. Now whatever is inside the function bracket, inside the function, that is input, and this is output. We all know y is equal to fx, isn't it? Y is equal to fx. So this 4 is x and the y is 11. So if we know x and y, then it will be very easy. Now that is x is equal to 4 and y is equal to 11. Same goes on another also. This is y is equal to fx. So this is x and this is x and this is y. So our input is 5 and our output is 13. Our pre-image is 5 and our image is 13. So that is x is equal to 5 and y is equal to 13. Y, this is our function. We have to use y is equal to mx plus c, and now that is equation 1. It is needed, so it's written equation 1. When x is equal to 4 and y is equal to 11, we use first case. This part first, x is equal to 4 and y equal to, we have to replace the y as 11 and x as 4. Now see, from this equation, y is equal to mx plus c. Now x will be replaced by 4 and y is replaced by 11. You can just see this is y is equal to m x is replaced by 4 plus c, isn't it? On 11 equal to 4m, just multiplying m for. Now we will we'll change the position here. You can see 4m plus c will change left hand side and right hand side. It can be done, sign won't be changed in this case. Now we will mix c alone. C is equal to 11 minus 4m. 11 is as it is on its own side. 4 changes its side, so sign changes. Though the student who changes the school at the end of academic session, they have to change the dress, isn't it? Same thing. That number or that value which changes the position, it changes the sign. Now we have to do next part here. This part, x is equal to 5 and x is equal to 13. Same. This is equation 2. It is needed, so it is written x equal to when x is equal to 5 and y is equal to 13. From 1 we will replace the value of x as 5 and y as 13. You can just see this is y, isn't it? In our question, y is equal to mx. X is replaced by 5 plus c. You have to practice many times. You have to practice lots of time, so that you will be familiar with the question. You will be habitual with the steps also. Mx plus c, y is replaced by 13 from here, isn't it? This is y, x, this is y. So now it's just multiplying. 13 is equal to 5m plus c. That is equation 3. Now here is c, isn't it? Here is c. Then we can replace this c with 11 minus 4m, isn't it? Value of c is 11 minus 4m, so we can substitute it. Let's see, putting the value of c from equation 2. We can see equation 2. Putting the value of c from equation 2 on equation 3. The value of c is 11 minus 4m. And you can just see here, 13 is equal to 5m plus, this is the value of c, isn't it? C from equation 2. Then we substituted the value of c from equation 2 to equation 3. Now this c is replaced by 11 minus 4. On calculation, you can see the calculation. 13 is equal to 5. We remove the bracket. 5m and 4m will be subtracted, and 13 and 11 will be subtracted. You can see 13 minus 11 is equal to m, because 5m minus 4m, it is m. Value of m is 4. This is our first answer. We found the value of m as 2. So now similarly, we will put this value of m in equation 2. Then easily we can find the value of c also. Putting the value of m in equation 2, c is equal to 11 minus 4 into 2. The value of m is 2, so we replaced m by 2. Now on calculation, c is equal to 11 minus 8. That will be c is equal to 3. We found the value of m as 2, 3 as c. Now if we put the value of m and c on equation 1, we will get the value of function, which is m equal to 2 and 3. You can just see, putting the value of m and c on equation 1 here, right here, we can put the value of m as 2 and c as 3. you just see fx is equal to 2x plus 3. This is m. 2 is the value of m. C is the 3 is the value of c. Now still we have to find the functional value of function f at x is equal to minus 2, at is equal to minus 2. So our input will be 2 when x is equal to minus 2, f minus 2. Now minus 2 replaces x everywhere, x, isn't it? On calculation our answer will be minus 1. This is very important question, a long one, and you have to follow each and every step very carefully, and you can do it. There is a practice question for you right after this slide. Let me show you. You can pause this video, you can try that question. Now try this. There are two questions. The first question is, if fx is equal to ax plus b, f minus 3, here input is minus 3 and output here x is minus 3 and y is 4, and you can see minus, this is x and this is y. You can follow the entire step. We just have to find the value of a and b. As I have said in the previous question also, this is a linear function, and linear function can be defined as y in any way. Even ax plus b, it is defined as ax plus b, right? And there is another question also. In the function gx is equal to px plus q. Now the linear function right in this question is defined as px plus q. If the image of 5 is 26, means 5 is x and y is 26. Image of 5's image is 26, means 5 is pre-image and 26 is image. And pre-image of 14, pre-image of 14 is x, 14 is y, and 2 is x. Pre-image of 14 means 14 is image is y, and pre-image of 14 is 2, means 2 is pre-image is x. You can do these two questions in exactly in similar way as we have done the previous question. Now let's move forward. Still we have few more questions. Now this is a very easy question. If you understand a little bit of indices here, you can do easily. Now solution here. Our function is defined at fx is equal to 5 to the power x. Our input will goes to the power of 5. First our input must be a plus b plus c. You can see in the left hand side, this is the left hand side, our input are a plus b plus c. So let's start. We start with from right hand side, sorry. Right hand side, you can see the input here. First input is a, second is b, and third is c. When x is equal to a, then a will takes the position of x, that will be 5a, 5 to the power a. A takes the position of x. See, a takes the position of x. Now when x is equal to b, here b takes the position of x. You can see b takes the position of x, and when x is equal to c, now c will takes the position of x. Now our input is x, a plus b plus c, then x will be replaced by a plus b plus c. F a plus b plus c is equal to 5a plus b plus c. Now we know a little bit indices, a law of indices. X m plus n is equal to, we can separate this, isn't it? If there are m plus n plus p also, that will be x to the power m dot x to the power n dot x to the power or p. So we can separate this also by the law of indices. fa, fb, fc. We can just see fa is 5 to the power a, 5a, 5b, 5c, 5 to the power a, 5 to the power b, 5 to the power c. You can see 5 to the power a is fa, 5 to the power b is fb, 5 to the power c is fc. So 5 to the power a, 5 fa, 5 to the power b fb, 5 to the power c fc. This is a very important question. You can just immediately you will see a practice question for this example. You can pause the video, you can complete your tasks. Let's move forward. The answer is given. Now try this. See the question on your screen. If gx is equal to 7 to the power x, then prove that m plus n plus p, just it is change of variable, isn't it? Nothing is different in both questions. Next slide, example 14. Now here we have to find the value of x by using this given condition gx. So for this purpose we have to find the functional value of function g at x is equal to x plus 1. Means our input will be x plus 1. Now let's see. It's a given gx is equal to x square plus 4x plus 5 is given function. Our input must be x plus 1. So when x is equal to x plus 1, now x will be replaced by x plus 1. Listen carefully, x will be replaced by x plus 1. See, all the x are replaced by x plus 1. You can see all the x here also, here also, and here also. Now we have to remember the formula of a plus b whole square. Now remember, there is a reminder, a plus b whole square is a square plus 2a plus we have to reduce this, we have to expand this x plus 1 which is x square plus 2x plus 1. Isn't it? A is x, so x square plus 2 dot x and dot 1, oh sorry 1 plus 1 square, that will be x square plus 2x, 2 dot 1, 2 dot x dot 1 plus 1. It is the expansion form. So it is then on multiplication for x plus 4 plus 5. Now what we can do, we can add that, we can add, is it 2x and 4x, that is 6x, 5, 4 and 10, that is 10. G x plus 1, the value of g x plus 1 is x square plus 6x plus 10. Now according to question we have gx plus 1 is equal to gx. It's given in the question. We know the value of g x plus 1 x square plus 6x plus 10. Let's substitute the value of gx plus 1, that is x square plus 6x plus 10. x square cancelled, 4x changes to left, goes to left hand side, it is minus, so 10 is on the right hand side, so it goes to left hand side, that also changes the sign. You can see 2x is equal to 5, you can see x is equal to minus 5 by 2. Our answer is x is equal to minus 5 by 2. We don't have to factorize also, isn't it? It's easy. Now let's quickly move to another question, and this is an example for you, a practice question for you. Try this. There are more than one question. So fx is equal to x square plus, similar type of question. You can see x square minus 3x, very much similar question. And this is also, here we have to find the value of fx plus 1 and gx plus 1. Then we have to equate it. And here input must be x plus 1, and for function g also input will be x plus 1. We have to find the value and we have to equate it. Now let's another question, 15. According to the adjoint, now the mapping diagram will be given to you, and from the mapping diagram we have to answer the question. Write the pre-image of 3. Now we have to be sure this part is x part, so it is a pre-image part, this is a y part, so it is a image part, and this is a, isn't it? So pre-image of 3 is the image, so pre-image of 3 are a and d, isn't it? This a and d is the pre-image of 3 because a and d are mapped to 3. This is image, pre-image. Okay, this is pre-image, this is image part. Don't get confused. This is domain also. These are the 1, 3 and 4 are the range also. The entire set is the codomain also. We have studied this. Now the answer, you can see answer from the mapping diagram are the pre-image of 3 are a and d because 3 is mapped to a and d. 3 is the image of a and d. 3 is the image of a and d. And now the next one is image of b is 1. Write the image of b and c. Now b is a pre-image, so its image is 1, and c is the pre-image, its image is 4. On 3, domain is a, b, c, d. The entire set a is domain because a, b, c, d. It is a function, so function, there is to be a function, every element must have unique image on set b. So entire set a is domain. Now range is 1, 3 and 4 because only 1, 3 and 4 are mapped. 2 is not mapped, so it is not part of range. And codomain is the entire set B. codomain is an entire set B. And which type of function is f? Now, which type of function is f? See, you can see the 2 is unmapped, so we can easily say it is an into function. You have to go back to the types of function. Then there is onto function, into function. So into function, then one element in the set B is totally unmapped. It does not have a pre-image in a set A, so it is an onto function. You can see the function f is into function, because range is a proper subset of codomain, or you can see there is an element in the set B which is unmapped, which does not have pre-image on set A. Next question is 16th. Fx is expressed in a different way. 3x minus 1, x plus 1. Find the value. We have to find the value of f minus 1, 0, and 1. But there are two functions right here. You can see there are two functions, and we have to select the proper function to find the proper value. Now, how to select? We have to select a proper function for proper values. In the first case, x is equal to minus 1, isn't it? In the first case, x is equal to minus 1, and minus 1 is always less than 0. And where is less than 0? Right here. You can see right here. Right here. It is x is less than 0, means 1 is less than 0. So our function for this part is x plus 1. So our function is, you can see fx is equal to x plus 1, and when x is equal to minus 1, x minus 1 replaces x, and wherever there is x is replaced by minus 1, you can see x is replaced by minus 1, the value will be 0. Now for 0, we have to find our function. To find f0, x is equal to 0. Now where is equal to? You can just see here is equal to, isn't it? Here is equal to. This is equal to sign. Okay, let me change the color. This is equal to. Here is equal to, x is equal to. So for our function, to find the value of f0, we have to use this function. This function must be 3x minus 1 must be used. So fx is equal to 3x minus 1, because it must satisfy the condition, because there are two functions and there are different conditions. So when x is equal to 0, 3 0 is equal to minus 1. So value of f0 is minus 1. So for next part, you can see in here also, as 0 replaces the x, isn't it? All the x is replaced by 0. All these x is replaced by 0. Now for 1, you can see for 1, x is equal to 1 means greater than 0. It is the same one. Same condition is applied. Same, because this is where x is greater than 0. 1 is equal to 0, x is equal to 1 means it is greater than 0, and for greater than 0, our function is 3x minus 1. F 3x minus 1, x is equal to 1. Now x will replace 1 will replace x, the value will be 2. In this way, we found the value of f minus 1, f0, and f1 also. Question 17. I think it is the last question. The function is defined in a different way, but not in an unusual way. The function is defined from set A to B, and set A it has elements, and set B also has element. And we have to show this in mapping diagram only and until we will find the which element maps to which element. We don't know. Minus 1 is mapped to which element from set B. We don't know. 1 is mapped to which element from set B. We don't know. First, we have to find. These are the pre-images. We have to find the image for the pre-image. Then only we can draw the mapping diagram. Now, the A are pre-images. These are x and these are y. And which x is mapped to which y? First, we have to find it. So when x is equal to 1, minus 1, and as we have our function fx is equal to 2x, x minus 1, x is replaced by minus 1. So we will get our value minus 2, minus 1, which is 1 by 2. uh, and when x is equal to 1, now 1 will replace x. You can see in the bracket also it is replaced, x is replaced by 1. Now it is minus 1. What we found is this minus 1, is mapped to this minus 1 will be mapped to 1 by 2, isn't it? And our 1 will be mapped to minus 1. And now let's see, 2 will be mapped to which value from set B. When x is equal to 2, now 2 will replace x. You can see minus 4, isn't it? Now 2 will be mapped to minus 4. Now let's draw the mapping diagram. In mapping diagram, see, we have to write entire set B and entire set A. 1 is mapped to minus 1 by 2, 1 by 2, and 1 is mapped to minus 1, and 2 is mapped to 4. So in this way we found image and pre-images, and that will help us in while mapping. And find the range of f. Now let's see the range. The range, these are the range, isn't it? Range is a collection of y, and these are all y. These are all y. From mapping diagram also we can write a range. Those elements which are mapped are range. 3 is not a range, part of range, so it is unmapped, so it is not a range. Now which type of function is this? As minus 3 is unmapped, 0 is also unmapped, so it is into function. As few elements on set B, does not have pre-image on set A, and also one image. Also for one image there is only one pre-image. Yes, for one image there is only one pre-image. It is one-to-one into function. You can write into function only. Also it is correct. You can write a one-to-one function. Also it is correct. You can write one-to-one into function. Also it is correct. Now let's move forward. Thank you for being with me till last slide. It is a 1 hour ride with you. This concludes workout examples of functions. See you next video. Till then, happy learning.